And hello all, and welcome back to another lesson on representing relationships. Now, we have discussed this before. Our goal is to represent relationships in 4 different formats. We'd like to say use words. We'd like to represent it with a table of values, a graph, and an equation. Just to bring you up to speed on what we talked about yesterday, this was Lightning and McQueen's relationship. Words, 30 miles per hour. Table starting at 0, 30 miles per hour. Equation starting at 0, 30 miles per hour. And graph starting at 0, 30 miles per hour. And we dug a little deeper into analyzing that relationship. Then we came about with that cheater, Chick Hicks, who had a head start, probably because he cheated, 75 miles away, 25 miles each hour. Already started 75 miles, then another 25 each hour. Starting at 75 miles, 25 each hour, and starting at 75, 25 each hour. Now we get to the king. This was your assignment from the previous day. Now, notice that the king did not cheat because he's got integrity. Starts at 0, goes up 50 miles per hour. Graph says the same thing. Words starting at 0, starting at point A. Distance increasing by 50 per hour, and starting at 0, which you don't need to write if you don't wish, 50 times t hours. 3 hours would be 150 miles, 16 would be 800. I'm going to stop reading. Go ahead and pause your video when you'd like. Come on back when you're ready. Now, at this point, some of you might be saying, Mr. Callan, is there ever a maximum? None of the 3 folks have had a maximum. Lightning didn't have a maximum. Chick could keep driving and driving. And so, well, I want to plant that seed and let it grow. When would there be a maximum, and what would a graph look like? Onward we go to Doc. We're going to finish up Doc and get into some guided practice from our textbook, ladies and gents. Doc Hudson is the man. It appears that they gave us a graph of his relationship d miles away from point A after t hours. So we need to come up with the words, the table, and the graph. Now I'm going to go here and I'm going to say, all right, most people like the table. Whoa, wait a second, time out. We see it right away. This is not a proportional relationship. It does not start at 0. Meanwhile, then, how much does it go down? After 1 hour, where is he? It's a little above 350. Is it 355? Is it 360? Is it 362.3798? That's going to be hard to figure out. Well, let's try to find some other nice points. Analyze that graph. Oh, there's a nice one. 5 hours, 200 miles away. And I did notice one more nice point right there at the end. 10 miles, 10 hours, 0 miles away. So look, ladies and gents, what we do, we now have a rise and a run. We have some mystery points in the middle, but there's no mystery about this. We see that he goes down 50, 100, 150, down 200 miles over the course of 1, 2, 3, 4, 5 hours. Oh, here we go. You can reduce it to negative 40 to 1. It goes down 40 miles each hour. So if you had guessed 360, you would be correct. If we go down another 40, that'd be 320. Down another 40 would be 280. Down another 40 would be 240. I'm going to pause, ask you to pause your video, finish up the rest of it. Come on back when your table of values is ready to go. And that relationship does match up with the remainder of the table. Now, where do you want to go from here? I'm going to go into the words. You are welcome to go into the equation if you want. Just pause and come on back. Now listen, Doc Hudson he begins his journey 400 miles away. And get this. His distance from point A, should I let him fill in the blank? Yeah, let me do it. If you want, pause the video, come on back when you're ready. The key word here, ladies and gents, we've talked about this in class. You need to use symbols or word phrases to say, look, 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 his distance is decreasing, it's going down. And in this case, it's going down by 40 what per what? Well, the miles depends on the hours. So let's say 40 miles for each and every 1 hour, 40 miles per hour. You can say it how you wish. P.S. If you did not notice the point in the middle, if you only noticed the 2 points on the exterior, you could have also set up a relationship of going down 400 miles over the course of 10 hours. And guess what? It still reduces to the same thing. So we can use constant rate of change as long as it's a straight line. We can use constant rate of change to find that. Down 40, right 1, down 40, right 1, down 40, right 1, and so on and so on. All right, let's get to that equation. I believe we noted that he starts 400 miles away. What happens to his distance? It decreases. How much does it decrease? 40 every t hour. Challenge, if you want, pause the video, rewrite that equation in a different way. Go ahead. Some of you might have put the negative 40 per t first, the positive 400 second. If you're looking for y equals mx plus b form, you can put it with y and x. All right, here we go. 3 hours, how far away? Actually, I would encourage you, pause, complete the rest of the analysis section, come on back when you are ready. 3 hours, 280 miles. 16 hours, ladies and gents, he has reached his destination. Let's go ahead and just state that he is 0 miles away. How about 2.5? If you do not have the number sense to look in between these, you can always use the equation. Starting at 400, go down 40 for all of those 2.5 miles. 240s is 80, a half of 40 is 20. Put that together and go down 100, and you'd find that he is 300 miles away. Yes, some of you have the number sense. You could figure out what is directly between 320 and 280. How long will it take to be 150? Oh, now that's tough. Little disappearing ink here will tell us it's got to be somewhere in between 6 hours and 7 hours, but it is not 6.5, ladies and gents. So here's what we're going to do. Let's go ahead and write our equation again. D distance equals 400 minus 4t, but in this case, it gives us 150 miles. So we need to go ahead and write 150 into our equation. Placing 150 into this equation, we need to now go ahead and solve for t. That's what we're looking for. How much time did it take? First things first, let's get rid of the 400 by subtracting 400 from both sides. Oh, this is where people start to freak out. Mr. Cowan, we got a negative amount. Sure you do. But when you divide by the opposite of 4, you would find that it will end up being a positive 250, which could be rewritten as 62 and that's what I get for trying to do it in my head. 250 divided by 4. 10, carry the 0. 2 fours is 8. 2 fourths. Something doesn't make sense here. Hold on, let me check my arithmetic. All right, folks, at this point you can laugh at me all you want because you see that I wrote 4 T's instead of 40 T's. So we got to divide by 40, not 4. Wake up, Mr. Callan. So here we go. 250 over 40, that can reduce to 25/4, which is 6 1/4 hours. Now that makes a little more sense because using your number sense, ladies and gents, you can kind of see that 150 is going to be a little closer to 6 hours than it is to 7 hours. My apologies, but hey, we all make mistakes. That's how we grow. I just got to make sure that I copy the equation more carefully. All right, onward we go. How do we represent the speed on the table? At this point, you recognize this from the previous day. It goes down. So let's say D decreases 40 as T goes up or increases 1. How do we see it on the graph? Down 40 and right 1, and down 40 and right 1. A rise, or should we say a fall of 40, and a run, or to the right, positive 1. Symbolic rule, we've already written it down. Just don't forget that negative is hugely important. You may write negative 41 to T if you wish. And we wrap up with a max and a min. The minimum, well, there is no point below 0. He arrives at his destination. He stops. We'll just say he stops. There is no point below 0 miles. But wait a second. Is there a maximum amount that Doc Hudson is away from point A? The answer is yes. Because again, you cannot go negative miles, ladies and gents. So this is his starting point, and there's no distance above 400 miles. So this is what a graph might look like that has a maximum value. All right, now that wraps up all of our link sheets for the CARS activity. From here, we're going to go into a guided practice. Homework for the evening, page 273, numbers 1 through 7. Page 273, I'm going to zoom in on the bottom portion. Page 273, and it does go on to the next page, page 274. Go ahead and write your homework right there. But you know, Mr. Callan, I'm not going to do your homework for you. You got to practice on your own. So let me guide you through some of it. Let's go back one page. I hope this is the correct page, page 272. Now, forgive me if I'm talking fast, but you can always pause, rewind, fast forward if you think you got it. Do your own work, fast forward and check your answers. Let's go through numbers 1, 2, and 3 together. Number 1, table shows the total number of text messages that Brad sent over 4 days. So we got a table here. Part A, write an equation to find the total number of messages sent any number of days, and then describe what it means in words. So first things first, write an equation. I'm going to write M equals. After all, the messages depends on the number of days. I further notice that the number of messages increases 50 per day and starts at 0. If you go backwards in the table, instead of going up 50, forward 50, you could always go the reverse direction to find your starting point. Now, you don't have to write the 0 if you don't want to. What does that mean? Well, we already said 50 messages each day. Write that in a complete sentence. Next part, using the equation, we would like to find how many text messages in 30 days. So I'm going to rewrite the equation. But we know the number of days. So instead of writing 50 times some missing number D, we're going to write 50 times 30. 5 times 3, 15, with a couple zeros for place values at the end, 1,500 text messages. Pause your video if you need, copy down what you need in your textbook, come on back when you are ready. Now, as we get into number 2, I want you to ask yourself, how are these problems similar? How are they different? Number 2, financial literacy. That's the study of money. That's the understanding of money. The graph, excuse me, shows the amount of money the Rockwell family budgets for food each month. Write an equation to find the total amount of money, C, budgeted in any number of months, M. So the first thing it's asking us to do again is to write an equation. They give us amount of money. Don't ask me why they use C. No idea. I guess we can't use money for M months and M money. Then we're going to use the equation to determine, well, what? We're going to determine how much money for 12 months. So again, what is the dependent variable? Well, we're going to use that C variable because the money budgeted depends on how many months we got. Please notice, little disappearing ink here. You could draw a line. Okay, good. This is a linear relationship. It's got a constant rate of change. How much is it changing? Well, it appears to go up $625 every 1 month. Now, folks, if you're having trouble seeing that, I don't blame you. Sometimes the graph and the scale is not very helpful for that. Then you have to be able to look at the numbers. From 625 to 1250 is up 625. Go up again. Oh, and by the way, it was a proportional relationship. So any of these, including the very last one, including the third one, you can just divide those numbers and you'll find the constant rate of change, 625 per month. It does seem to start at 0. Only put that plus 0 if you wish. All right, write an equation, check. Determine how much money. Let's rewrite the equation. What is given to us? Oh, we're given the money. So let's put in 12 in for the months. We're given 12 months. Let's put 12 in for the months. Let's find the budgeted 625 times 12 is $7,500. Once again, pause if you need to. Come on back when you're ready. So both of those problems give us some representation of a relationship. Problem 1 gave us a table. Problem 2 gave us a graph. Both of those we could rewrite or translate the table and the graph into an equation because it might be kind of a pain in the butt to go all the way to, what was this first one, 30 days. Can you imagine the graph going all the way to 12 months? But the equation, ladies and gents, is an efficient way of finding out the answer without having to graph or extend our table further. On to number 3. Again, if you'd like to at this time, pause, do it on your own, come on back when you're ready. A store receives an average of 7 movies per week. So, part A, write an equation. What depends on what? Well, the number of movies will depend on the number of weeks. So I'm going to write M equals. We know there are 7 new movies each week, and it doesn't say we start with anything. You can write the 0 or you can just leave it be. Part B, make a table to find 4, 5, 6, and 7 weeks the number of movies that are watched, and then graph. Now, my table, I'm going to put weeks first. I'm going to put movies last. After all, the movies depends on how many weeks we're watching for. Notice the strange thing here. They don't want us to start at 0. They want us to start at 4 weeks. Okay, so 7 times 4, 28. What if we did 5 weeks? Well, 7 times 5 is 35. 6 weeks would give us 42, and 7 weeks would give us 49. So I can now take those and I can extend that into an ordered pair. 4 weeks is going to be 28 movies. 5 weeks will be 35, 6, 42, and 7 for 49. Now, you are welcome, if you wish, to draw a line, or should I say array, because there's no such thing as negative movies, through those points. And if Mr. Callan can draw straighter points or a straighter line, that'd be great, huh? Notice this is proportional. There's no starting value. There's no starting fee. Question 4, how can you use a graph to write an equation? Well, I'm going to encourage you to answer that on your own and then fill in, yeah, how about that? An arrow. Lovely. Fill in, are you ready to move on? Or wait a second, I need to email Mr. Callan or email Miss Morris or email my teachers right now. Maybe you're kind of in the middle. Okay, I'm getting this for the most part, but I think a little more practice checking odd answers in the back of the book will help. Ladies and gents, onward you go to your homework assignment, page 273 and 274, numbers 1 through 7. That's what I got, folks. Take care, do well, and let's grow.